Hi, I am Shika. Welcome to my revision class. Today we are going to revise the first topic, states of matter. If you want, you can pause the video and write notes if required, and all the points in the syllabus will be discussed in this video. States of matter. In this chapter, we are going to study about the structure of solids, liquids, and gases, the process that leads to the change of states of matter, heating and cooling curves, interconversion of matter using kinetic particle theory, and the effect of temperature and pressure on the volume of gas. Structure of solids, liquids and gases. You can see the structure of solid, liquids and gases in the diagram. So here we are going to discuss the differences in the structure of solid, liquids and gases in terms of particle separation, particle arrangement and motion of particles. So in solids, the particles are very close to each other. In liquids, the particles are close, and in gases, the particles are far apart. In solids, the particles are arranged in a fixed and regular pattern. In liquids, the particles are arranged in an irregular pattern, and in gases, the particles are at random. Motion of particles. In solids, the particles show tiny vibrations. In liquids, the particles can slide past each other, and in gases, the particles can move very quickly in all directions. Changes in states of matter. Matter can either exist in solid, liquid, or gaseous state. They can also be converted into the different states by either heating it or cooling it. Solid can be converted to a liquid by melting, and liquid can be converted to a gas by a process called vaporization. Gas can be converted to a liquid by a process called condensation, and a liquid can be converted to solid by a process called freezing. In some cases, a solid can be directly converted into a gas, and this process is called as sublimation, and the reverse, that is, the gas can also be directly converted to solid, and this is called as deposition. Differences between boiling and evaporation. Boiling. Boiling occurs at the entire length of the liquid, whereas evaporation occurs on the surface of the liquid. Boiling takes place at a specific temperature, whereas evaporation occurs at any temperature. Bubble formation is visible during boiling, whereas bubbles do not form in evaporation. Boiling occurs rapidly, evaporation occurs slowly. The definition of sublimation. Some solids, when heated, directly changes into gaseous state. This change of state is called sublimation. Volatile liquids. They are liquids which evaporate easily and have a relatively low boiling point. Kinetic particle theory. Here we are going to explain melting in terms of kinetic particle theory. You can also see the diagram of the melting of a solid to a liquid. So when a solid is heated, its particles get more energy and vibrate more. At melting point, the particles vibrate so much that they break away from their positions and the solid becomes a liquid. We are going to explain boiling in terms of kinetic particle theory. In the diagram, you can see the changes that are taking place when a liquid is converted into a gas. When a liquid is heated, its particles get more energy and move faster. At boiling point, the particles get enough energy to overcome the forces holding them together. They break away from the liquid and form gas. Here we are going to explain condensing and solidification in terms of kinetic particle theory. When a gas is cooled, the particles lose energy and move slowly. When the particles bump into each other, they do not have enough energy to bounce away again. They stay close together and a liquid forms. Solidification. When a liquid is cooled, the particles slow down even more. Eventually, they stop moving except for some tiny vibrations and a solid forms. Heating curve. The heating curve for a substance shows how the temperature rises with time when the solid is heated until it melts and the liquid is heated until it boils. So this is the diagram of a heating curve. When a solid is heated, the temperature of the solid rises. At a fixed temperature called the melting point, the solid starts melting. During this process, the temperature remains a constant. The heat provided is used to overcome the forces holding the lattice together. In this area, you will be finding both solid and liquid, and finally, at this time, all the solid is converted into a liquid. And when this when all the solid has completely melted, the temperature starts rising, and at a fixed temperature called the boiling point, the liquid starts changing into a gas. So in this area you will find both liquid and gas, and finally at this point all the liquid gets converted into a gas and the temperature of the gas starts increasing. So this is called as the heating curve. Cooling curve. A cooling curve shows how the temperature of a substance changes with time as it is cooled from a gas to a solid. Below is the cooling curve of one substance. How can you tell that this substance is not water? Now let us look at the graph shown here. So a liquid turns to a gas at its boiling point. So here the boiling point of the substance is 78 and a solid changes into a liquid at its melting point, and here the melting point is minus 15. So the substance has a boiling point of 78 degrees Celsius and a melting point of 15 degrees Celsius, whereas water has a boiling point of 100 degrees Celsius and a melting point of 0 degrees Celsius. So the substance is not water. Identifying the state of a substance at room temperature. How will we find out the state of a substance at room temperature when its melting and boiling point are given? A substance which is a solid at room temperature has melting point and boiling point above room temperature. Usually the room temperature is taken as 25 degrees Celsius. A substance which is a liquid at room temperature has melting point below 25 degrees centigrade and boiling point above 25 degrees centigrade. A substance which is a gas at room temperature has both melting and boiling point below room temperature. Effect of temperature on the volume of gas. When the gas is heated, the particles collide with the walls of the container more often and with more energy. So the plunger moves out. This means that the gas fills a larger volume. Effect of pressure on the volume of gas. When force is applied to the plunger, the particle gets close together and occupies a smaller volume. So when the pressure on the gas is increased, the volume of the gas decreases. Thanks for watching my video. I hope you found my video useful. Please like, subscribe and share.